Welcome back. This is chapter 13. And in this video, we're going to start out with talking about constructors. Now, a constructor is a special type of function that is automatically called when an object is created. The purpose of it is to construct the object, which I know that sounds pretty straightforward, but it's something to remember because that's the point of it, is that you are constructing an object. When you first instantiate or you create a new object from a class, you're constructing that class. And so that's why they're called constructors. The name of that function and how your compiler knows that it's a constructor is the function name is the name of your class. It's the same as your class. Now, here is an interesting thought process. A constructor has no return type. It depends on who you talk to. This saying has no constructor type, as in there's no void out there, there's no int, there's none of these things, and we're about to take a look at it. But I do want you to take note and think about this. A constructor actually does return something. In fact, when the constructor is called, it returns the object itself. So it constructs the object and then returns the constructed object in its own right? So, and we'll talk about that here in a moment. So let's kind of take a look, see if we can jump in here. So we've got this rectangle, and we've got all the things that we've been talking about. We've got the private, the public. We've got some inlines, which is great. Don't forget the if not defined, then define it in the end-if. We can tell that this is an H file, not only because they call it, but that's why they're defining the rectangle.h. So this is an H file, all understood there. And here is a constructor. So remember, the class name is rectangle. So the constructor is also rectangle. But now, remember, you got rectangle from type of rectangle, and then you got the double colon. And so what I'm saying here is when we call this rectangle, it's going to come into this constructor and do these things, and then technically it's returning back an object that's of type rectangle. Kind of keep that in mind, a little bit of thoughts on that. And this is the rest of the rectangle class. So again, when we call rectangle box, it's defining an instance of the rectangle. And what's happening here is when we see out the width and the length, we're going to get the zeros because up here in our constructor, we now are setting these to 0. So again, if you're using C++ 11 or later, you can initialize a member variable in its declaration statement just as you can with a regular variable. This is known as an in-place initialization. So here's a little bit of an example. We've got the width, and we are doing an in-place initialization. All classes have a constructor. And that's because without a constructor, there's no way to construct the class. So if you don't specify a constructor, under the covers, we have what's known as a default constructor. It will always take no arguments. And basically, and again, this is where, the book says that it doesn't return a type, and I would argue that it returns itself as a type. So that default constructor is there when you don't create a constructor, and that's because when you call the class, you make an instantiation of that class, it needs to still call some kind of constructor to construct the object. It's just nothing will happen, and there's nothing in the constructor, nothing like that. Passing arguments to a constructor. Well, how do we do that? If I go up here again, we look at our constructor, there's nothing in here. There's no way to pass in variables. I know. How do we do it? Well, we can actually create constructors that have incoming parameters. And then when we define it, and that's how we know we're defining it, we're going to define what those variables should look like. And in this case, we're going to set those private variables that technically we don't have access to unless there's some kind of public function. Maybe like a rectangle, the constructor. Because the constructors, by the way, are public. Passing arguments to constructors. So here again, we are initializing and creating a rectangle type of R, but because we're using this, we're going to use the overloaded, by the way, this is known as an overloaded constructor. Just like we've talked about in the past, overloaded functions, that's what you're doing here is you're overloading a function. It just happens to be the function that's a constructor. So we can do some interesting things with constructors. So if all of a constructor's parameters would have a default value, then it is a default constructor. So because we're giving it these default values, we can call this constructor the default constructor. It's because if you don't do anything in the code, it doesn't matter. The fact is that, or you don't call these, the fact of the matter is, like this, you're not actually making use of these variables, but because they were assigned, it doesn't need you to make use of them. It basically says, hey, if the programmer passes something in, then use it. Otherwise, use a 0. So you can call it without the params, and it still knows what to do. And again, this is what we were talking about briefly here a few slides ago. If you don't specify a constructor, let me back that up. Sorry about that. I got a little bit ahead of myself. So what this slide is saying is you can have classes with no default constructor. When all of the classes constructors require arguments, then the class has no default constructor. When this is the case, you must pass the required arguments to the constructor when creating objects. So in this case, what they're saying is if you develop a class that has a constructor, here's my pen, here's my constructor, and it has params, but I don't specify that default value, then that's saying that this class has a constructor but does not have a default constructor. And because we've done this, you have to use this constructor and you have to pass in those values, otherwise you'll get a compilation error. Well, if we have a constructor, then wouldn't it make sense that we can also have a destructor? A destructor, just like a constructor, is automatically called when an object is destroyed. To name something as a destructor, it's the class name, but with this little tilde sign in front. So we've been using the rectangle class as our example. This little tilde with the word rectangle is what allows us to know, lets the compiler know that that's the destructor. And it has no return type, very similar to the constructor, and takes no arguments. And unlike constructors, where you can have multiple, you can only have one destructor per class, and you cannot overload. So these are the big things that are the difference between constructors. Sometimes the pen gets a little crazy on me. So again, we've got constructor and we have destructor. We can overload, cannot. We can have multiple, cannot. Those are the big pieces. Now, why might we want to have a destructor? Well, the big reason is one of the big reasons, and oftentimes probably the biggest reason, is to clean up. So if we have an object that creates dynamic memory, so I'm not even saying when you instantiate this class as an object, and if you did it dynamically, that's great. What I'm talking about is if you have methods in your class that within the class create dynamic memory in different places, your destructor is what would clean those things up. If you don't clean up dynamic memory in classes, when you destroy the object, then you will get a memory leak. So, dynamic memory can equal memory leak if not cleaned up. If only we could see an example of a deconstructor. So here we have, this is the H file, right? And we've got interesting, we've got private, and we've got some items that are private. And we've got some public, some items that are public. One of the things that, and again, this is known as the inventory item. So our constructor, right there. As you notice, we don't have a default constructor for this. We don't have an inventory item like that. And we also don't have one that is like this, where we have inventory item. Well, really can't. Well, I guess you could. You could say you could go through and you could assign default values for all of these, and then you would technically have a default constructor. But I don't want to get too far off on that because it just doesn't have it. We can see, we can look at this, and we can go, okay, there are no default constructors because we only have the one constructor, and it clearly is looking for input. And there's no default value set for it. And then down here, we've got our destructor. Now, what's interesting about this destructor is that it's inline. And we can do inline. The reason why it's doing that delete is because way up here, we're creating this memory. And if we don't delete it, when this object goes out of scope, there is no way to get back to that description. uh, this actual variable, and there's no way then to perform the delete. And because of that, we have memory leak. And this is just using that particular item. Now remember back when I was saying, well, constructors, they say that constructors don't return a type. This seems very much like we're calling a method that's returning a type of R, type of rectangular. So that's kind of why I tend to go down that path of, you know, I believe that constructors do return a type. It's the type of itself. But remember, when we use the word new, we're allocating dynamic memory, and we must make sure we delete it. If you are writing one of your pieces of homework and you forget to delete, you will lose quite a bit of points because this is such an important thing. All right. When we come back in the next video, we're going to talk about overloading constructors.